Good afternoon, everybody. Welcome to this webinar on market perspectives for biomass-based CHP. My name is James Ling. I'm working for Greenovate Europe in Brussels, a network of organisations dedicated to sustainable innovation. I'm co-moderating this webinar. I'm firstly just going to tidy up some organisational issues. So all of our attendees are in listen-only mode. But we absolutely welcome all of your questions through the chat box. So please don't be shy and put all your questions to our panelists. We will have time set aside to answer those questions, so please ask away. Aside from that, we are recording this session, so it will be available afterwards. Also, the presentations will be shared with you. I think that's about it for the technical information. If you have any technical issues or problems with the sound, also please put it in the chat box and we can try and correct those things. And with that, I will hand over to Giulio to tell you more about today's webinar.
Thank you, James. Good morning, everybody. My name is Giulio Poggiaroni. I'm from the European Biomass Industry Association, EUBIA, and I will give you a very brief introduction on today's webinar. So, market perspective for biomass-based CHP. It is a BIOCOGEN 2030 initiative, and if for those of you who don't know BIOCOGEN, BIOCOGEN is an open network stakeholder platform which was launched back in spring by two Horizon 2020 projects, Blaze, where where EUBIA is partner and I'm working for, and the SmartCHP project, where James from Greenovate Europe works for. The aim of the platform is to gathering stakeholders active in the field of biomass CHP, enhance knowledge sharing among the stakeholders, promote innovative biomass CHP technologies and linked solutions, and provide a debate forum like we're trying to do today. This is a short glimpse on the related BIOCOGEN pages on both the Blaze website and the SmartCHP website. Then some brief information on the two projects that launched this initiative. So the Blaze project aims at developing an advanced small medium scale CHP plant which combines gasification and the use of solid oxide fuel cells. On the other side, the SmartCHP project is will design and will build a new small-scale CHP, this time utilizing pyrolysis and diesel engine. For today's agenda, I'm pretty done with my introduction. We will have a presentation from three companies active in the CHP sector. We will first have Nikos Sakellariou from EXERGIA, then Dirk Bonse from AHT Syngas, and then Egbert Freiherr from Cramm from ENTRENCO. And then at the very end, we will have 15 minutes for answering your questions. So pretty much it from my side, and I will pass the word to Nikos. The floor is yours.
Good morning. This is Nikos Sakellariou. I represent the SmartCHP project, and this project. Can you see my screen first of all? I believe yes. This is a SmartCHP project. It's a project which is being funded by the Horizon 2020 initiative program. And in this project, there are quite a lot of partners. There are 10 partners involved and contributing knowledge, namely BTG, Abate Motoren, CAPEX, Dowell, DTU, Greenovate, EXERGIA, OWE, OVI, TEHAG, and the Eindhoven University of Technology. All these partners come from 6 countries, bringing the project knowledge from all these countries. And a project of 4 million spans a period from June 19 up to May 2023, when we're going to deliver the output of the outcome of this project. We combine industrial expertise together with university expertise and consulting expertise. So we are trying to develop a product, in fact, that will be able to cover market needs, but at the same time contribute to the exploitation, to the use of biomass in the form of bio oil for cogeneration of heat, generation of heat and power. What is this project and why smart CHP? Cogeneration, we all know what it is, generation of heat and power, but smart in that case, the smart component lies in the fact that it combines not only a use of energy, but a renewable energy, which is a biomass in the form of bio-oil, and at the same time, it utilizes renewable energy sources, name it solar, name it wind, name it whatever it is. So through a smart control, in a way, it takes the most out of its renewable energy source and tries to develop, tries to meet the demand of any facility in the market. It is a highly flexible, small scale though, up to 1 megawatt CHP unit in the range of 100 kilowatt up to 1 megawatt. And it is produced, it is fueled with fast pyrolysis bio oil. This bio oil is produced from different types of lignar cellulosic biomass or residues, mainly biomass residues, agricultural, forestry, or organic waste residues. We have already started developing the engine that will utilize this bio-oil. You can see at the right of the screen this engine, which is being in the test laboratory, in the experimental laboratory, and being tried with the bio-oil in order to see also to develop components of the engine that can utilize this fuel. Schematically, we collect the non-food biomass through a fast pyrolysis liquefaction plant. We will produce the bio-oil from different residuals. It could be olive kernel, it could be wood, it could be whatever, miscanthus, whatever. And we have this modified diesel engine, and also at the same time this engine cooperates with a flue gas boiler. It has a flue gas boiler, but also cooperates with another boiler which works together with the engine in order to meet the heat or electricity demand through a smart control unit of any industry, any commercial center, district heating, but also remote areas, because it provides the electricity but also the heat. A multiplicity of applications can be served by this system, or the scope is to be served by this system. It has quite high flexibility, at least this is the what we plan to deliver, high flexible system which integrates renewable energy sources. You can see there PV wind, but could be any other renewable energy source. But one thing that is important, and the aim is to have the fuel to have standardized characteristics in order to be distributed broadly in the market. Existing units can be retrofitted in order to be able to make use of the system and be able to be revamped in order to make use of the system and adapt their existing, if any, cogeneration unit to use bio-oil, that is, and smart CHP technology. It's a typical CHP unit, so it is very easy to use and operate, but one very important dimension of this technology is that it reduces a lot greenhouse gas emissions compared to fossil fuels used in CHP currently. There have been certain KPIs, key performance indicators for this project, which you can see in the screen. We target an overall energy efficiency more than 85%, out of which 40%, more than 40% will be the electric efficiency. This at standard conditions at 80% engine load. And a very important characteristics that the consortium is targeting to achieve is to have this variable heat to power ratio ranging between 10/1 to 10/1 within a wide range of load from 30 to 100%, giving the user of the system, of the smart CHP system, to meet its heat or electricity demand profiles. Overall, the system, because it uses again, biomass, and according to the RED II methodology, aims to reduce more than 80% greenhouse gas emissions. Such a system, in order to be attractive, should be financially viable and attractive. So the target capex will be less than 1,200 euro per kilowatt electric, and the opex the target is to have an opex of less than 150 euro per megawatt hour at having the conditions that you can see there, that is 100 at a price of fuel between 210 to 120 euro per ton at this calorific value of 16 gigajoule per ton. You imagine that CHP, or you know that CHP is quite an attractive technology. So far, the efforts that have been done have accelerated CHP technology in some countries, in some regions, decelerated CHP technology because, for instance, subsidy schemes or incentives have been removed or funds have finished. So CHP sometimes has faced quite some problems in terms of the enabling, let's say, environment. But now we believe that there are quite a lot of market drivers, not only market drivers, that could allow CHP and, of course, our project Smart CHP to have a successful route in front. It is the EU vision to 2050, decarbonization, that is, of the economy. But again, in the shorter term, that is up to 2030, we have the Green Deal, which sets quite specific targets. Let me, for instance, say that the vision to fit the Green Deals goes for 30% share of renewable energy sources. Smart CHP utilizes this. 30% energy efficiency improvements, or 40%, approximately 40% reduction in greenhouse gas emissions. So the broader picture is there, the vision is there, And also there are quite a lot of factors, regulations, schemes that enable CHP, green technologies, CHP, green CHP, our CHP, biomass CHP, in fact, having the chance to get quite a big market share and contributing this vision and the Green Deal, of course. What is the market? The market of CHP is the smart CHP market. Hotels, health facilities, shops, malls, office buildings, public buildings, residential sector, public, especially public residential blocks, perhaps through small-scale district heating and cooling. And also the industrial sector, the small-scale industrial sector requiring, with lower capacity demand, can be quite a good market segment for this, of course. And of course, the agricultural business, the agribusiness. And the agribusiness is quite a good, greenhouses, for instance, could be a good customer for smart CHP. Now, we have tried to quantify the market for CHP. So we have used the methodology and approach that would allow us to figure out what the market would be. So we have defined several market segments, for instance, hospitals, hotels, offices, malls, residential complexes, greenhouses, etc. And we have tried through a methodology to find what is the quantity of this market in some areas. So the first step was to assess the volume, to see how much the volume of each market segment is, and of course to match, to get information, to find information and process information on the specific energy consumption of each one of these market segments. Then what we have done has been done within the project. We have tried to see what is this part of this segment, of each segment, that could become CHP or smart CHP user. So we have estimated somehow the quantity or the capacity of this, or the volume of this market segment. Over there, you can see at the back of in this part of the screen, a graph. We have there, for instance, hospital facilities. There is a distribution according to the size of these facilities. But not all sizes can use the smart CHP within the range 0.1 to 1 megawatt. So, for instance, in this case, you can see that hospitals in the range between 200 up to 500 beds could become user of CHP technology. These have been quantified in order to give us the market potential and for further analysis. In order to do the analysis and quantify the market, we have selected 5 countries, focus countries, which you can see over there: Croatia, Greece, Romania, Sweden, the Netherlands, in order to play the role of pilot countries for the implementation of a smart CHP, Croatia, because there are quite a lot of land, quite a lot of pieces of land where miscanthus can be cultivated. Greece, because of Knolle, Romania, Konstover, Sweden, because there is softwood forestry residues a lot, and the Netherlands, which can import, because the logistics exercise, how to treat the produced bioil should be tested within this project. So we'll import pyrolysis oil from Sweden. So having quantified all those market segments, In these 5 countries now, we believe that there is a potential, which you can see more than 50 smart CHP units could be the market of smart CHP in Croatia, more than 100 in Greece, more than 150 in Romania, Sweden, more than 100, same for the Netherlands. Okay, one may think that this is a big number, or another may think that this is a small number. It is up to us, up to the framework, to be able to attain this market, but the market is there, and this is what we have to take benefit from. Thank you very much for your presence there, and I would like to thank also the Smart CHP Consortium for allowing us to present to you our project. Thanks a lot.
Thank you, Nikos. Now the floor to Dirk Bonse from AHT Syngas.
Yeah, thanks very much. I'm starting now to share my screen. So you can see it all. My name is Dirk Bonse. I'm the sales manager of AHT Syngas Technology NV. We are operating from near Cologne, although we are a Dutch registered company. And today I would like to speak about market advantages and market outlook of medium-scale biomass heat and power plants, which we offer, and our experiences, challenges, solutions, and lessons learned in these markets. Sorry. Okay, so the agenda would be a short company introduction in relation to medium-sized cogeneration solutions. Then I will report a bit on decentralized energy provision strategies. As I said, based on our experiences in our core markets. I will draw some conclusions from that. And finally would like to discuss the options of rethinking cogeneration in terms of tri- and quadruple generation. So what we basically offer are 3 business lines, let's say. So we have pure, raw, and clean gas solutions for industrial applications where process heat or process cold is needed, in a range from 600 kW thermal up to 50 MW thermal. We offer the true cogeneration clean gas solutions for decentralized power plants in a range of minimum 200 kW electrical up to 12 MW. Basically, we have 2 lines from 200 kW and 1 line of 500 kW approximately, and these we can then cascade to achieve higher outputs. Our services comprise feasibility studies, engineering to design such a system. We think here more project-wise than having 1 unit which is sold. Of course, we deliver, we erect, and we supervise also by remote control, and do of course also support, third-level support but also help with maintenance during, let's say, the learning curve of an operating team, and spare parts and wear parts handling. Our value chain consists of course, consulting and empowering clients, the design and customization of a system to the needs of the client, the sales, of course, the shipment and the implementation, maintenance and services, and we are also very active, also quite recently now, in R&D and engineering. Short glimpse on our history. We have quite a long history because more or less we stem directly from Nikolaus August Otto, who invented the first gas engine, which already ran on a syngas. At that time it was called city gas. He later founded Klöckner Humboldt Deutz, maybe you all remember those pictures from let's say the late 40s when Germany did not have access to fossil energy carriers, where every lorry had its own gasifier in the back to actually deliver the energy to a gas engine. Later on, Klöckner-Humboldt-Deutz was defunct, and because Germany had again access to fossil fuels. But then again, with the oil crisis in the late 80s, there was a renaissance of this technology. And finally, the first generation of AHT took the technology, the base technology of the twin fire gasification from KHD and brought it into a new company. And we are now more or less the third generation of this original AHT, let's say. This is what a typical gasification array looks like. So we have the twin fire gasifier. We have a wet gas cleaning we can apply, but also in combination dry gas cleaning, depending on the feedstock quality. Actually, we have a water treatment system because we recirculate the water for the process. So during normal operation, additional water would not be needed. And then, of course, we have the CHP unit or the genset, depending how much heat a customer, for example, would like to have. So we have several options to decouple heat. That's from the engine jacket, of course, from the exhaust gas, but also we can install, for example, hot gas filters to produce more heat. This depends always on what the customer's wishes are. I would like to lose a few words about this twin fire gasification that I've mentioned. It's basically a combination of updraft gasifiers and downdraft gasifiers. So in the case of an updraft gasifier, the syngas is stripped off against the flow of the biomass. This leads to an effect that you have a relatively high tar content, but at least a low ash content. A downdraft gasifier does it the other way around. So the gas is stripped off with the biomass flow, let's say. And as one can maybe imagine, this leads to at least a low tar content, but a relatively high ash content. And in both cases, the material is usually not completely gasified. So what we did actually is to combine it both. So we have the co-current flow with the biomass, but also air is entrained in the opposite direction, and the syngas is stripped off somewhere in the middle. So basically, two gasification zones form, and this combines actually the advantages and disadvantages of both technologies, because already in the product gas, we have low tar content and low ash content, and an almost complete gasification, so that more or less only pure ash is entrained. A look on feedstocks that we can use. Surely the classical wood chips. We can also use harvesting residues. We can briquette them. Coconut shells are also welcomed. Can roll compact them, for example. We always need a kind of coarse structure. So for our gasifiers, they are 8 meters in height, more or less. Pellets are not so suitable. And we can, of course, also use liquid biomass. How we do that, I will explain a little later, in form of sewage sludge, of manure, or digestate, which we turn then in a hydrochar, which has a brown coal-like characteristics from the heat value. Yeah, some of our references, which I will also use after that to speak a bit about the markets. Here in Indonesia, we have installed 6 megawatt coal gasification in this case. It can actually be adapted later to biomass, especially to hydrochar from carbonization. And the electricity was fed to a city nearby, basically. Sorry for the delay. This is one of our most recent projects where we combine such a carbonization unit with gasification. And feedstock is basically hydrochar from sludgy material like manure and sewage sludge. The carbonization unit is already working. Due to the pandemic. The installation of the gasification system was interrupted, and all parts are there. We simply actually have to put them together now. And here we have an electrical output of 200 kW electrical, and in this case 158 kW thermal, which is partly refed also to the carbonization process, but also will be used for near distance heating of buildings, own consumption for the electricity, but also will the rest be given to the grid. This is an installation that we finished last year in August. The client in Indonesia, he has an own technology developed to form hydrochar by fast pyrolysis or wet pyrolysis actually, which is similar to carbonization. And we have installed the pilot plant, where also the task was to train the operation team, and we already have also delivered the engineering, the complete detail engineering for a 10 megawatt installation. This is maybe one of our most known projects, at least in Japan. It's a kind of lighthouse project. So the output is 800 kW electrical with 2 gasification arrays, which I have shown before. And it runs on wood chips. And yeah, gas, heat, and power is being produced. And if you look here, you can see my mouse in the picture in the lower left corner. You see here a hotel. So this actually shows how clean such a plant from us works. So there are silencers in the chimneys, the exhaust chimneys. Also the flares are protected, for example. And this hotel with another hotel, they receive waste heat from a hot gas heat exchanger for the famous Japanese onsen spas. Maybe a little fun fact. This is so close. The operators are not allowed to enter the roof on during special days. These are the days when the women are entering these famous onsen spas. So then they cannot enter for maintenance the roof. Yeah, coming now to some of our experiences, strategies, to draw the cycle to the topic of this webinar. So in Germany, we look back on many installations in the heydays of high feed-in tariffs in the early 2000s to 2010s. We were awarded contracts, a contract during European-wide tender for a research facility quite close to us here, where also the Technical College of Cologne is involved. Of course, not only in Germany, as well in whole Europe, we are at the moment facing the fact that feed-in tariffs fading out. And also we are in a kind of limbo. Just yesterday, I attended another webinar because everybody is actually waiting in all countries what will happen 2021. So politics and the lobbyists, of course, and the other organizations that are discussing how to promote especially biomass or cogeneration from regrowing feedstock or even from biogenic waste. So everybody's looking how is this going to happen, which effect it will have on feeding to grids. So there are a few strategies discussed, but there's no clear strategy at the moment. So how do we address that or overcome that? At the moment, we are concentrating on delivering process heat from which also cold can be generated for industries, for dairies, agriculture, for own consumption, including heat, of course, from cogeneration. delivery of baseload and balancing capacities for hybrid systems. So to actually deliver the baseload, for example, in systems where solar and wind are integrated. And there are also in Germany, at least, there's a special program at the moment to promote the use of biomass or switch from fossil energy carriers to biomass for process heat. We are looking very much also as a standalone solution in hydrothermal carbonization, which I have mentioned before, which is also a kind of biogenic waste valorization. And in this form, as it is inertized during the carbonization process, it can also be brought back actually on soils. Our latest product is H2 separation from syngas. The good thing is syngas already contains hydrogen, 15 to 30%, depending on the gasification agent. And this way, you simply need to separate it. You do not need to synthesize it by electrolyzers, for example, which are very costly. In Switzerland, yeah, as I have said, the first combined HTC and gasification plant in Switzerland and possibly also in Europe for the further use of manual sewage, sludge and digestates. And with this, we are addressing also the waste reduction topic, as these materials, as I have said also in Germany, cannot be brought back to the soils anymore. Challenges in Switzerland are especially obtaining the approvals for erection and grid connection, so there's a lot of bureaucracy. On the other hand, Switzerland embraces especially the use of biogenic residues, especially wood. We can also use treated wood, for example, which is lacquered, for example, waste wood. And yeah, there the situation is a little bit better actually in Switzerland. Also, heat is a topic there. Near distance heat is a very hot topic in Switzerland. Still also the feed-in tariffs are relatively comfortable. Also, Switzerland, of course, consists of very small communities in the valleys or even on the mountains. And there's a lot of agriculture and animal industry which have their own waste and could benefit then from combined heat and power and cold production. We also formed their local partnerships, also with university for research and development and for also developing further the carbonization technology. So we're taking now a jump overseas to Japan. Japan still has the highest feed-in tariffs in the world, and apparently there seems to be not much changing during the next couple of years or the next years at least. And our experience is then the aforementioned gasification plant, which serves 2,000 households with electricity and the 2 hotels with heat. What we are facing is currently this difficulty to apply for grid connection, especially for medium or large scale biomass power plants. Because everybody wants to do it due to the high feed-in tariffs. So our solution is that with a new client now, we are looking in what can we do with the syngas. As I have said, we can separate the hydrogen from it, but we can also separate, of course, carbon monoxide and carbon dioxide, which are elements which are used during chemical processes. And we are performing now with a new partner. Especially in Japan, we experience that it is, of course, very important to have local partners for sales and operation to actually overcome language and also culture barriers. Indonesia is very special. We have the experience of the coal-fired power plant and the small pilot plant. The challenge is that the actual client needs to individually negotiate with the state-owned utility provider, and the decisions are not always clear, to say the least. So we have solutions, especially for these markets, which have a broad range of feedstock. Also, fossil is still an option there. because coal gasification at least is still cleaner than incineration. But as I said, we also tell the clients you can switch later if it's needed, if you want it. Also here, local partnerships are important, not so much because of language or culture barriers, but of course there is a price sensitivity, and we are in exchange with partners so that we can have uncritical plant parts manufactured locally to lower actually the prices. So drawing some conclusions, as I've said, currently it's a little bit unpredictable regarding subsidies or incentives, which are expected then for 2021 in Europe, but also in Southeast Asia. So we concentrate at the moment a bit more on self-consumption of industries or agricultures, for example. Because we can deliver a high availability for industrial processes, high efficiency, more than 19%, both for heat plus electricity. We deliver baseload capacities, which is important, as I said, also for smart city concepts, for example, and the integration of other CO2 neutral technologies. Cogeneration redefined. So we think that also the material uses of syngas and biogenic residues is an option. Waste reduction is also a topic that is addressed actually with gasification of biomass or biogenic residues. And to realize that, we need, of course, always a little bit pre-work to study actually the surroundings. Where can I get feedstock? What kind of feedstock? How do I need to pre-treat it, for example? And finally, also we look, of course, it can offer financing options up to contracting. Just as an example here, what is possible. So we can use a broad range of feedstocks, which we can either put to the hydrothermal carbonization to generate a hydrochar, which either serves as soil improver or is being put to gasification. The solid residues, waste wood, RDF, harvesting waste can go directly to gasification, possibly briquetting and drying is to be applied. We have then the separation of syngas constituents, the processed water. We can produce fertilizers like phosphorus or ammonium sulfide by vacuum distillation, for example, and of course the tri-generation power, heat and cold. Few words about the up and downstream technologies. The hydrothermal carbonization is actually a process that works a bit like Mother Earth. So also Mother Earth use temperature, pressure, and time to form coal, and this we do here as well. Of course, we do not need millions of years. We have then the hydrogen separation, which is, as we think, the missing link actually for producing green hydrogen, because by a special technology which uses physical quantum effects, hydrogen particles are tunneled into a tube, which is of pure iron. And this way, we do not need much energy to separate the hydrogen from the syngas. So this broadens actually the client space, which is possible with cogeneration. So on the one hand, of course, we can address clients which have own waste from sewage sludge plants, wood processing industries, farmers, and of course, food and beverage. Especially here, there are in need of heat and cold, for example, but also high temperature processes like welding or calcination, who are requiring very high temperatures, more than 1000 degrees. Power producers, especially independent power producers, which is more a topic in Asia, and the chemical industries to use the syngas constituents. So this is my presentation. I would welcome some questions, especially regarding looking beyond cogeneration, as I said, tri or quadruple presentation. And here you see our premises in Bergisches Land in North Rhine-Westphalia in Germany. Thank you very much.
Thank you very much, Dirk. Before passing on to Egbert, I would like to remind the audience that they can submit questions in the panel that will be addressed at the end of the presentation. So, Egbert, the floor is yours now. Yes, we see you in the presentation. Egbert, you are muted. Try to speak. I don't hear you. No, we don't. I don't hear. James, do we have?
I'm not sure what the problem is. It shows that he's unmuted.
Oh yeah. Maybe try to remove him from the presenter and then make him again presenter.
Shouldn't really be connected with the sound at all, though.
No, we don't hear you.
Oh dear, the best made plans.
Egbert, do you have headphones or something you can use? Okay, perhaps if you try to solve this issue, we can I can read for the time being. I can read a question that came from the audience, which perhaps can address to Nikos and Dirk, which is a question related to what is in your mind the optimal size of a CHP plant according to the availability of local biomass. So Dirk and Nikos, if you want, you can try to address this question. In the meantime, Egbert tries to fix the problem. Nikos, go.
Okay. Okay, let me, as you can, as presented, the range of sizes that of some CHP is between 100 kilowatt and 1 megawatt. The size depends on the size of the facility. The size of the installation will depend on the demand, but at the same time depends on the availability of biomass in the area. I mean, of biomass, of bio, which is quite can be used at a reasonable price as a fuel, that is. So to our understanding, and this is going to do in the course of this project, is to try different sizes of different CO2 units around. But to our first we believe that sizes between 100 and 500 kilowatt could be the sizes most attractive in terms of usability and feasibility to install, because not that many big appliances, big facilities are available, not because they do not have the need, but there are some constraints that have to be met as well, like, for instance, the bio storage, or the frequency for storing bio oil and moving around trucks, etc. So in order to have something reasonable, something which is acceptable, and something does not interfere with the surroundings, but also fits with the dimension, the requirement of the facility, something reasonable in size should be used. Also take into consideration the energy content of bio-oil, which is approximately 40% of, could be up to 50, but approximately 40% of oil. So you need 2.5, almost twice as much volume for the same energy input. So putting all these together and the size of facilities that are around, which are not enormous, because enormous will go to different sizes, different technologies, etc., or very big installations. We believe that a range between 100 and 500 kilowatt could be. Yes?
Egbert, try to speak. Because I had the I had the impression we could hear him, but no, I'm very sorry. Egbert,
no,
you could try to leave the webinar and try to re-enter. I don't know, because it says your audio is on, so I don't know what's the problem. Try to leave and then reconnect. Sorry, Nikos, go.
No problem. So it is, and this is going to be tested, of course. That is why we have chosen 5 different countries in order to see to meet the demand of certain facilities while testing the engine, the system, not the engine, that is, but also to check the logistics in order to make it feasible and profitable for the final consumer, because it is, we have to keep a balance between certain things, and in order to meet the supply of technology, equipment, and oil with the demand of the facility. First understanding is that we're going to move around there. That would be the most, say, common sizes that will go to the market.
Okay, Dirk, if you want to add something.
Yes, thank you. I more or less agree with Nikos. I also see, a good size around 500 kW electrical for several reasons. In our case, for example, this is also the limitation because of physical and chemical principles of gasification. So it cannot be installed much higher, but we can multiply it. We also have this line, as I said, of 200 to 200 kW, which is from the price performance ratio not so optimal, because it's not really much cheaper, let's say, as a 500 kW installation. It's more or less the same parts. But there's also another effect, especially in earlier days, I would say even until last year, there are always, barriers, let's say, for the feed-in tariff. So there is a typical limitation, for example, of 499 kW, for example, in Greece, or in Southeast Asia. There's also a limitation sometimes with 1 megawatt. So we, of course, prefer to install course 1 megawatt, 3 megawatt units, but of course you also need to see is the grid capable to take that in. If you are grid connected, if you are off grid, it's another topic. We are also experts in off grid installations or microgrids, for example, as we have this baseload capacity. So this is what I see actually as the drivers, let's say, for the optimal size. of course, the available amount of feedstock is a topic. In our case, just to visualize it, we need, for example, 680 grams to generate 1 kilowatt hour. This is the case with wood chips, which is more or less the most beneficial and most easiest to handle feedstock.
Okay, thanks. Egbert, no signs of the audio trying to respond. No. Have you tried to disconnect and reconnect to the webinar? You could use the same link.
If I might, maybe I have a suggestion, Egbert. Did you maybe switch on your computer the tone on and off? Like with a button or something. I always forget it as well, and I have the same problem.
No. Well, Egbert, of course, feel free to try and interrupt us if you manage to solve it. I suggest you try to disconnect and re-enter. In the meantime, we could address another question, which is perhaps linked also to some consideration we did before organizing this webinar, which is something that you, Dirk, mentioned in your presentation, the production of hydrogen. So, in market-wise, do you think that biomass CHP plants are ready to face new wave? We all know that hydrogen is pretty fashion now, and do you think the CHP plants are ready for exploiting the potentials of hydrogen in the coming years? Dirk, you're muted. And switch on.
Yeah, the thing is, at the moment, the whole world looks in hydrolyzers, electrolyzers for that matter, which demand a huge energy demand. And so people discuss about taking the energy from offshore wind parks, from huge solar installations, and then pipelining the hydrogen. So what we offer is that we can produce the hydrogen even also in smaller amounts directly where it's needed. And to speak about the CHPs, yes, they are actually ready. I mean, if I look at a CHP from the perspective of the electricity generation of energy, there it is even beneficial if you do not have the hydrogen anymore, because the higher the hydrogen content, actually, this is sometimes a drawback for some so-called lean gas engines. So if we only have the CO, which is the main energy carrier for such gensets, it's actually beneficial. So we can have both. We can strip off the hydrogen, but we can still use the rest of the syngas for gensets. So this is actually an optimum combination, out of my mind. And yeah, as I said, now it's to convince also the policies to look into these decentralized solutions and not the centralized hydrogen solutions, which are currently being discussed, and where also the infrastructure still needs to be established. Pipelining, energy provision, energy transfer. Yeah, and yeah, from our end, we have the solution already here to do it quite effectively at very low cost. And then from biomass and biogenic waste, of course, which is regionally available.
Okay. James, we have other questions from the audience?
Yeah, I'm just reading one for Dirk about the valorization of liquids. Is it also possible to valorize manure? Are there active installations with pig, chicken, or cow manure?
Yes, most definitely. So pigs and pig's manure and cow manure are very good material, very beneficial. It's already quite liquid, because for the so-called hydrothermal carbonization, as we do it, we need a very high moisture content actually to process it in a continuous process. Chicken manure is also not a problem. Either we can use a sister technology, which is called vapothermal carbonization, which is a batch process, which basically works like a pressure cooker. But we can also, for example, moisture such waste, chicken manure, for example, to re-moisture it with the processed water, which we anyhow produce. So this is an option. The same applies with certain digestate from certain biogas plants, which maybe where also the leftovers are not really pumpable. So conclusively, we simply make it moist and then it works.
Can you hear me now?
Wow!
Yes, now we hear you.
Very good.
I've restarted. Do we still have time?
Yes, try to be quicker, but yeah, we can have your turn. Go on.
Okay, I will.
Yeah, go on. You see your screen. Yeah.
So our product is a standardized CHP of 50 kilowatt electric and 120 kilowatt thermic, which is put into a container to make the implementation time short and standardized. Our vision and value proposition is to develop CHP turnkey solutions which are already embedded into the parallel use of electricity and heat. And we are also very closely working together with complementary providers so that we can develop a seamless solution for our clients. What are currently the challenges in this industry? Many CHP units in the past have been unreliable and very expensive in maintenance. CHPs produce ash, which is in some countries considered as toxic waste and will be more and more severely monitored. Many units are sold to the field without having a clear after-sales strategy. Uptimes are often exaggerated. Up to now, CHP are still very expensive compared to market prices without subsidies. And the simultaneous need for using heat and electricity in the same place requires intelligent business development strategies and also very sophisticated data analysis. The technology is still for many users relatively new, particularly in developing countries, and the customers demand complete solutions. So we have to make sure that we can deliver end-to-end solutions which are seamlessly interfaced into other products of other vendors. And last but not least, service and monitoring is key. So if we look at our market approach, what are we looking for to design or to qualify a market as attractive? We need a positive political environment for renewables, an acceptable feed-in tariff, and we have to have an acceptable price for the heat, because the cogeneration also is a co-sale for the electricity and for the heat, which is required. The price for the feedstock should not be too high. In some instances, it should also even be a paid feedstock. And it should be available. We have heard about Japan, and we can only underline this remark that feedstock availability in Japan is sometimes very difficult, as difficult as grid availability. And of course, the intensity of competition. If these parameters are given, then we of course look at the market volumes, the electricity utilization and the heat utilization, and we have to come to a meaningful payback period for the investment of our clients, and we also predict this and calculate this together with them. So from this analysis, I would focus on two attractive markets. We have already heard about Japan with the highest feed-in tariff and a very high awareness for renewable energy due to the Fukushima catastrophe. We have seen that there is a lot of demand, but on the other hand, it's a challenging market because you have to deal with large power plants and you have to deal with forest unions in order to get enough feedstock. In Italy, the market has been completely blocked over the last 2 years because the political parties couldn't find a solution on the new feed-in tariff scheme. It's still not decided, but when it will be decided, it might become an interesting market again. The largest utility, Enel, is a very renewable energy conscious provider, and also the Italian people are very keen on getting green. Germany is, as we all know, one of the most environmentally conscious countries on the globe. While politicians so far have favored wind and solar and did not really focus on the need for baseload energy, which was provided by coal and nuclear, and because this is now changing, and we also will have a new EEG, and we will have a newly introduced Brennstoffemissionshandelsgesetz, which is sort of a national emission taxation. We hope that Germany will also become a more attractive market in the future. I've talked about the need for a service concept. We monitor our machines online in order to be in a constant dialogue with our clients. But let me briefly come again to the market and the advantages of biomass. We see here the carbon intensity of various generative options. So compared to coal, oil, natural gas, you see that biomass has a very, very attractive footprint. And this is on the next chart exemplified on the additional price which will have to be paid from somebody who is using, for example, energy with fossil fuels. And if you look at the upper line, this is the blue line, you see this is electricity. Normal electricity will be punished because in Germany it is currently very much dependent on brown coal and on hard coal, and has a very high CO2 footprint with a significant tax, which goes up to about 30,000 euro for the equivalent amount of energy which could be produced with 150 kilowatt CHP unit. And this will, of course, add up to quite a significant amount over the lifetime of such a piece of equipment. So what are the use cases? We have briefly characterize them into two groups, electricity and heat, and what you can do of the heat if there is not an easy heat usage. So electricity for internal consumption is in many instances the most productive and best way. It is currently in Germany pretty highly taxed with fees. Electricity sold to the grid depends on the feed-in tariff, and the decentralized microgrid electricity is mainly attractive for remote areas in many developing countries, but also in scarcely populated countries which have difficulties to provide the infrastructure in remote areas. So the heat we can use direct for process heat. We can, if there's no other means, convert it to electricity via an ORC. We can convert it to cooling via absorption cooling, and we can also in tropical countries convert it to fresh water from the air. Very few examples for applications. You see here a classical direct heat usage in a wood drying plant in Japan, or you see the greenhouse heating in a vegetable growing plant in the UK. This is CHP, which we have only a week ago implemented in Japan in a so-called eco village, where we have a completely decentralized power generation and heat generation cycle, so that they can get off the grid and still have electricity and heat in an eco village. There are several heat use cases for cooling. I will just briefly run through the different applications. The biggest one are commercial air conditioning and commercial refrigeration. Second is industrial air conditioning and industrial refrigeration, and transport is not that interesting for us. You can see that there is a significant increase in cooling demand, and there are two countries which are outstanding in their demand. One is China and the other one is India, but also in other countries there is a continuous increase in demand, and you see here also pretty strong growth rates, for example, in Indonesia and in Mexico. And just to give you an overview, cooling compared to other goods and services on the upper left chart in the middle shows that there's quite a significant amount of global market potential. And if we go to these different sectors, we see that domestic refrigeration and also residential air conditioning are very strong sectors which become very attractive, particularly in developing countries. There's another interesting use case, heat to water. For example, we are in cooperation with a company called Grubs, and they have developed a technology this allows water to take it from plain air. Of course, it needs a certain humidity, but we are in operating in cases where this is very attractive, particularly in remote areas. Last but not least, heat to electricity. Everyone knows the ORC technology, which is it's a second choice because it is still too expensive and the conversion rate is pretty low, but nevertheless it is in some instances better to provide this than not be able to use the surplus of heat. Another interesting sector is the ash to biocoal conversion, where we have developed up to now a prototype which will be able to convert the toxic ash to a valuable fertilizer. We have received a very positive certification, and our CO content of the biocoal is about 80%. Sorry for rushing through this presentation. I hope I have regained some of the lost time. Thank you very much.
Thanks very much, Egbert. I'm really happy we could finally hear you and see your presentation, so thanks a lot. I'll just pick one question from the audience. It is, what are acceptable feed-in tariffs and value for heat?
Well, as we know, the feed-in tariff in Germany is currently around 13 euro cent, which definitely is too low to make a difference. I would say whatever is above 20 is an attractive feed-in tariff price. And for heat, and I'm always talking per kilowatt hour, and for heat, I would say everything which is beyond 4 euro cent is already attractive.
Very good, thank you. Giulio, I don't know if you had any other questions you wanted to pose, or whether you are all ready to close the webinar.
No, we have run out of time, and yeah, luckily we had the chance to have Egbert presenting. And sorry for the inconvenience, and I hope this was an interesting webinar for all the attendees. The recording of the webinar will be available soon, and be sure to visit the pages of BioCogen 2030 on LinkedIn and on the respective pages of the project, so the SmartCHP and Blaze. And subscribe to the platform if you haven't, to be updated with our upcoming initiatives. And we look forward to see you next time. Bye-bye.
Bye-bye.
Thank you very much. Bye-bye.